This presentation is the suggested solution to exercise 2, modeling a conceptual model of a zoo. We will use UML class diagram to create the conceptual model based on a domain description. And here is the domain description. And I recommend you to pause this presentation and read through the domain description before we continue. Your task is to represent the concept and terms in the domain description by creating a conceptual model using UML class diagram. Here is another guidelines, and this guidelines regards event action classes. And these are the classes that has a date as an attribute. In front of you, you see the event action class registration. And these guidelines state that for each business event happening, for each registration happening, you need to create a new object. You should not reuse objects in event action classes. For example, say that 5 registrations happened the same date. Then you need to create 5 objects with the same date value. So in this case, you can see that 2 events has happened and each event has created 2 objects with the same date value. Then if new events happen the next date, then you create new events, but then you change the date value, of course. Note that you do not model the objects in conceptual modeling, but this way of thinking influences the multiplicity in the conceptual model. The first thing you do when you create a conceptual model based on a domain description is to identify the major concept, the major nouns. We can start with these 3 concepts: the zoo, the animal keeper, and the administrator. And we create classes of these 3 concepts. The next step then is to identify attributes or characteristics of these major concepts. For example, zoo has name, address, and telephone number. Animal has name, species, gender, birth year. Animal keeper has name, mobile phone number, and employee number. Administrator has name, mobile phone number, and employee number. Note also that the animal could be born at the zoo or be bought from outside. I have now added the attribute to the classes. Note also the attribute born at zoo in the animal class. I have there a parenthesis with a Y and an N, yes or no. With this, you usually show that this attribute born at zoo has a Boolean value. It could either be yes or no, true or false. So that's the reason why you model this Y and N in parentheses. The next step is to identify the verbs, the major verbs. And we have registered, that animal has to be registered. We also had that the animal keeper has to be is responsible, and both administrators and animal keepers are employed. So now let's model these verbs using associations. You can see in the diagram here that the administrator and the animal keepers are employed by the zoo. We can see that the administrators registers animal and animal keeper is responsible for animal. A problem here is that we need to document the date for the registration. And these dates for registration need to be an attribute of the association registers. But that's not possible to have an attribute on an association. So what you need to do then is to create a new class, registration. That means that you transform the association to a class. And this registration class can have the date, register date. And we can see that registration is made by the administrator, it concerns an animals, and it concerns a zoo. Note that the two classes, administrator and animal keeper, has the same attributes, and also they have the same association to the class zoo. This indicates that we can create a more generalized class out of these two classes, and we will do that and call that class employee. And we will put the three common attributes in this more generalized class, and we will also associate between the zoo and the employees. We create this association between the employees and zoo. Think now that we want to create an object of the administrator class. Then that object will inherit all the attributes and the association from the more generalized class, from the superclass. That means that the administrator object will have the three attributes with values for each of these attributes. And also that object will have a link to a zoo object when it's created. Let's continue with the domain description. We can see here that an animal has an animal keeper that is responsible for the animal. We have already modeled that. But this paragraph also states that the animal keeper can be responsible for several animals, but an animal can only have one responsible animal keeper. This sounds like business rules, and usually you model business rules using multiplicity. So we will now try to start modeling the multiplicity between the animal keeper and the animal. And the multiplicity looks like this. I now try to describe in detail what we mean by this. Think that we have two objects of animal keeper. We have one animal keeper, Arne Stor, and one Eva Björk. And we have two animals, the lion Leo and the tiger Alice. In this case, Eva Björk is responsible for the lion Leo and the tiger Alice, while Arne Stor is not responsible for any animal. Let's check the multiplicity rule. It says that one animal keeper can be responsible for minimum 0 animals and maximum many animals. Because when we read the direction from animal keeper to the animal, we find the multiplicity close to the animal. And this multiplicity seem to be consistent with the objects that we now have modeled. We can see that Arne Stor is not responsible for any animal, and that's okay since the minimum value of the multiplicity is 0, meaning that one animal keeper object does not have to have a link to an animal object. And the maximum value, many, represented as a star, shows that one animal keeper object can be related to several animal objects. Remember the rule: when you go from animal keeper to animal, you hold one object in your hand and ask, how many objects of the animal can this animal keeper object be linked to minimum and maximum? When you go in the other direction, you hold up an animal object and ask the question, how many objects of the animal keeper can this animal object link to minimum and maximum? In this case, it's 1 to 1, means that one animal object has to be linked to exactly one animal keeper. The lion Leo is linked to exactly Eva Björk, and the tiger Alice is linked to exactly one animal keeper, Eva Björk. So the multiplicity and the objects that I have shown here is consistent. We do not violate the multiplicity rules. Now I changed one of the links. So now we have a link from Arne Stor to the lion Leo. And see what that's what the indication consequences of that will be. In this case, Leo is linked to Eva Björk and Arne Stor, which means that if we go from animal to animal keeper and check the multiplicity, we see it's 1 to 1, which means that one animal object needs to be linked to exactly one animal keeper object. But this is not the case now on the object level, because the lion Leo is linked to 2 animal keepers. So we now violate the multiplicity rule. So either we have to change the multiplicity rule, or we must say that the links between the objects are wrong. Let's continue in the domain description. The last paragraph says that administrators and animal keepers are employed by one zoo. They cannot be employed by several zoos. Again, this sounds like a business rules, and usually business rules are represented as multiplicity. Here we have the two classes, employee and zoo, and the association between them. Employed by employee. An employee is employed by a zoo. We also here add the multiplicity following the description, that an employee, if you read from employee in the direction from employee to the zoo, we see that one employee object need to be linked to exactly one zoo object, as mentioned in the domain description. If we go in the other direction from zoo to employee, we can see that one zoo object need to minimum be linked to one employee object. That means that the zoo object cannot need to have a link to an employee object, and a zoo object can be linked maximum to several employee objects. Let's now check this with some objects. We have 3 employee objects: Arne Stor, Eva Björk, and Georgios Samaras. And we have 2 zoo objects, Stockholm and Athens. We see that Arne Stor and Eva Björk are employed by Stockholm Zoo, while Georgios Samaras is employed by the Athens Zoo. Let's check if this is in accordance with the multiplicity rules. We know that one employee object must be linked to exactly one zoo object. See if that's true. Georgios Samaras is linked to exactly one zoo object. Arne Stor is also linked to exactly one zoo object, and Eva Björk is linked to exactly one zoo object. So in this direction, the multiplicity and the objects are consistent. We go in the other direction, from the zoo to the employee. And the multiplicity from zoo to employee is 1 to many. And that means that a zoo object, one zoo object, must be linked to an employee object as minimum, and can be linked to several employee objects as maximum. Athens, the zoo object Athens is linked to one employee object, so that's okay. And Stockholm in this case is linked to 2 employee object, and that is also in accordance with the multiplicity rules. We will continue discussing multiplicity, but now we take a larger part of the diagram model so far. We have now 4 classes. We have the registration class, we have the zoo class, we have the administrative class, and we have the animal class. And the registration in this case is like a spider in the middle, have association from the registration class to the 3 other classes. We will now add the first object, which means that we now register an animal and creating a registration object. And that registration object is linked to an animal object, the Bo bear. It is linked to a zoo, Athens, and it's linked to an administrator that did the registration, Georgios Samaras. Let us now add another registration object. Now we register a new animal, in this case bear Noah. The registration object is also linked to Athens, as well as to the same administrator Georgios Samaras. Now we try to add the multiplicity in this case. We start from the registration object. We can take the registration object to the left and think how many, in this case, if you go from the registration object, from the registration class to the administrative class, it has to be exactly one registration object has to be linked to exactly one administrator object. And that is true in this case. If we go from registration class to zoo, we have the multiplicity 1 to 1, which means that the registration object has to be linked to exactly one zoo. And we can't see any violation in the multiplicity rule here. And in the same way, the registration object need to be linked to exactly one animal, and we can see that the object here is also linked to one object, animal object, bear, boo. If we go in the other direction, from administrator or from zoo or for animal down to the registration object, we have the multiplicity 0 to many. We can try one of the ways. So if we take an administrator object, that object does not need to be related to any registration object, but it can also, but maximum it could be related to many registration objects. So we can check Zlatan and Georgios here. We start with Zlatan. Zlatan is not linked to any registration object, and that is okay according to the multiplicity rules, which says that the minimum is 0. The minimum value is 0, which means that an object of the administrator class does not need to be linked to a registration object. Georgios Samaras is linked to 2 registration objects as you see. But that's also okay, since the multiplicity rule says that one administrator object can be linked to many registration object maximum. We have the many the maximum many represented as a star, as a little star. An interesting notation here is that towards registration we have 0 to many. From registration we have 1 to 1. And the reason for this is that the registration class is actually a class that represents business events, and they are usually identified by they usually have a date as an attribute. So the registration represent business events happening in the business, and these usually have this pattern of multiplicity. They have 0 to many towards them, and they have 1 to 1 from that class to other classes. We are now back to the diagram that we have earlier on in this presentation. A question here for you. If you have access to a registration object, can you find the animal keeper that is responsible for the animal registered? That question should be able to be answered based on this diagram with the multiplicity. So if you have access to a registration object, can you find the animal keeper that is responsible for the animal that was registered? Let's check. I just now show that part that are of interest in the diagram. We have the registration. We created a registration object, and that registration object requires and the multiplicity between the registration and the animal class shows that every registration object need to be linked to exactly one animal object. And in this case that's true. The registration object here is linked to the tiger Alice. Note now the relation between animal and animal keeper, and if you go from animal to animal keeper, the multiplicity is 1 to 1, which means that one animal object must be linked to exactly one animal keeper object. This means that if we have the registration object, we also find the animal object that was part of that registration, and then we also have the animal keeper that is responsible for the animal. So the answer to the question was yes. Now I have added paragraph in the end of this domain description. During the introduction of an animal arriving at the zoo, a veterinarian needs to carry out a medical investigation, documenting the medical status and the date for the investigation. The veterinarian has a name, a mobile phone number, and an employee number, as well as an expert area. Let's check how we model that. You can see that we created a class called medical examination, which is again a class that represents business events, which I usually call event class or action class. That medical examination is associated to the veterinarian class as well as the animal class. The attributes for the veterinarian were similar. Were the same as the three attributes in the employee class: name, employee number, and mobile phone number. So again, the veterinarian class became a specialized class of the more generalized class, the employee. But since one of the attributes was not part of the employee class, we keep that attributes in the veterinarian class like this. The medical examination also concern one animal. So now let's add the multiplicity. And we can see that medical examination is an event class, and they usually have zero to many towards these classes, and they have usually 1-to-1 from these classes to other classes. And this is the case. It is the case in this case as well. So we can see that some classes in your diagram are representations of business events: registration, medical examination, and they are identified, as I mentioned before, that they usually have a date as an attribute. Another characteristic is that it often has zero to many multiplicity towards them, and from the event classes towards other classes is usually a 1-to-1 multiplicity. Let's now elaborate around the generalization specialization relationship between employee, the administrator, the animal keeper, and the veterinarian. We do that by adding objects. We can see that an object of the administrator is Georgios, that an object of the animal keeper is Eva Björk, and that the veterinarian, and an object of the veterinarian class is Steffi Graf. Administrator class, animal keeper class, and veterinarian class are more specialized classes of the more generalist class employee. Administrator, animal keeper, and veterinarian class are usually called subclasses to the superclass employee. The three objects the three objects, Georgios, Eva Björk, and Steffi Graf, are also objects in the employee class. That means that an object, for example, Eva Björk, is part of this object is, so to say, represented in employee class, and other parts are represented in the animal keeper class. And this will be obvious when we try to create an object based on the diagram. For example, we create an object, a Steffi graph object. Steffi graph is an object of a veterinarian. And the veterinarian has one attributes expert area which will get the value. But since veterinarian is a specialization or subclass to the employee class, it will also inherit the other three attributes and get value for these when you create the object, as you can see here. Not only that, the veterinarian, when we create an object of the veterinarian class, it inherits not only the attributes, it also inherits the association. And since we now create an object, it's going to be a link to another object, in this case the Berlin Zoo. I will now end up this long presentation with some guidelines that we can use. When you start modeling a conceptual model, you can have as a starting point, as a starting guidelines, that nouns are modeled as classes or attributes, and verbs as associations. Sometimes when associations need to have an attribute date or some other attribute, you need to transform the association to a class. So in this case we created a registration class. Another guidelines is to very early identify these action event classes, and they have this special pattern of multiplicity, not always but often, that has 0 to many as multiplicity towards the action event classes and 1 to 1 from it. And it simplifies the modeling to early find these action event classes. Here is another guidelines, and this guidelines regards event action classes. And these are the classes that has a date as an attribute. In front of you, you see the event action class registration. And these guidelines state that for each business event happening, for each registration happening, you need to create a new object. You should not reuse objects in event action classes. For example, say that 5 registrations happened the same date. Then you need to create 5 objects with the same date value. So in this case, you can see that 2 events has happened, and each event has created 2 objects with the same date value. Then if new events happen the next date, then you create new events, but then you change the date value, of course. Note that you do not model the objects in conceptual modeling, but this way of thinking influences the multiplicity in the conceptual model. Here is another guidelines. Objects are by default unique. So in front of you, you can see that 2 objects has the same value, the same registered date. But still, each of these objects are unique. It's a kind of a hidden rule in conceptual modeling that all objects are by default unique. Later on, if you want to add a unique attribute, such as, for example, a registration ID, you could do that, for example, when you transform this conceptual model to a database scheme. But if registration ID is not used in the business, you should not model it. Look now at the administrator class. Here you have a unique identifier attribute, employee number, which gives each object a unique number. In this case, it is okay to have that attribute if the business use the term employee number. Here is a guidelines that we not talked about before. Some attributes shall be classes because each attribute should only include one value when it's instantiated to an object. In this case, maybe the employee want to have several. Maybe you want to show that the employee can have several phone numbers. And since when we create an employee object, we can only give one value to the mobile phone attribute. In this case, we need to create a new class, mobile number, in order to handle that. And now we can store each mobile number as an attribute and link that to the employee. And if you go from employee, from the direction from employee to mobile number, you can see that multiplicity is one to many, which means that one employee object can have many mobile number maximum. So this was the way to handle that you want an attribute to have several values. Another guidelines is that you should make use of generalization. In this case, you can see there are similarities between administrator, veterinarian, animal keeper. They are all employees. And you create then a more generalized class, and all the attributes that are in common you use as attribute for this more generalized class. So make use of generalization is possible. It makes the conceptual model easier to interpret. And finally, a very important rule. When you do conceptual models, you should not model the objects. I have used objects in this presentation just to make you think in the right way when you think about classes and the multiplicity. But you should not model the object. You should not model these blue things when you do your conceptual model. You could do it in your head or on the side or on a sketch, but the thing that you sort of say hand in should not include object. You should only model classes and association. You should not model objects and links. But you have to think about it when you carry out modeling. Thank you. A task. Finally, I have a task for you. One of the attributes in this model could be questioned. Which attribute do you think it is and why? As some of you already had figured out, it is the born at zoo attribute that caused some problem. It is a Boolean attribute, which means that it has only two values, yes or no. But still, this attribute could mean different things. First, it could mean that the animal is born at the zoo, or that the animal is born at nature, which means that if it's born at the zoo, it will have yes, the animal will have the value yes the whole life. While if it's born in nature, it will have the no the whole time. Another interpretation is if the animal is born at the latest zoo it is registered at. For example, the animal is born at one zoo, then they will have the value yes. Later on, the animal move and get registered at another zoo, and then the value would change from yes to no. And if it moves again, it will keep the no value. For the last interpretation, it is actually better to move the attribute to the registration class as it is done here. That means that if an animal is born at the first zoo, the first registration object will have the value yes. Then when it moves, the second registration object for that animal will have the value no, and so on. So now you can search for all registration for this animal and go back and see if it was born at any of these zoos. So you get a better traceability by moving the attribute to the registration class. An even simpler solution is to have an attribute in the animal class called place of birth. And here you could, as value, be specific and say if the animal was born in a certain zoo by have the value of the zoo name as a value. Or you could also here give the value where in nature the animal was born, if that's possible to specify.